Now we're going to look at quadratic equations and problem solving. We have got about 4 different ways to solve a quadratic equation. In this video we're going to look at 2 of those methods. The first one, with my little red arrow, we're going to solve quadratic equations using factoring. Now the principle of zero products states that an equation a times b is equal to 0 is true if and only if a is 0, b is 0, or a and b both are 0. So this means I have got to get factors, which leads me into my next example. When you are solving quadratic equations by factoring, all terms, non-zero terms, have to go to one side of the equation. It is to your advantage to make sure that your x squared term is positive. It's a little bit easier to factor if you do. So in this first one, all my terms are already on one side. It's a binomial, and I always look to factor out a common monomial, so I can factor out x from both of these. So I end up with x, and in parentheses, x plus 7. When I get it down to this step, I separate my factors individually and set them equal to 0. So in this one's already solved, so I've got x equals 0. This one I need to subtract 7, so x equals negative 7. So my solutions are x equals 0 or negative 7. Either one of those, if I substitute back in, will make a true statement. In this next example, if you'll notice, not all terms are to one side. Go ahead and put them in descending order at the very get-go, and it's one less thing you have to do. So now, if you factor this, notice I'm going to have x minus 5 in one parentheses, and the same thing in the second. Now, I don't need to set both of these equal to 0, because they're both the same thing. I set 1 equals 0, I end up with x equals 5, and my solution is x equals 5. It's called a double root because I would have ended up with 2 if I set both of those equal to 0. So now I've got some of the following problems. I need you to work these, so pause me, do all 3 of them, and then turn me back on and see if you agree. Okay? Now in this particular problem, everything's already over to one side, and it's one of those nice kind, so you should have x plus 3, x plus 4, or vice versa. Set them individually equal to 0. Let me pull it on down. Well, there it is. So I would end up with x equals negative 3 or x equals negative 4. And again, if you can check these, store these values, type in your equation, and you'll end up with 0 equals 0. So you do have a nice way to solve these equations and check them. This one, let me see, I'm going to take these 2 terms to the other side, so I'm going to have 12x squared plus 17x minus 5. Factoring this, this one proves a little bit more difficult, but it can be factored, so you should end up with 4x minus 1 in one parentheses and 3x plus 5 in the other. Set them individually equal to 0, and then solve. Here I would add 1, then divide by 4, so x would equal 1/4 here. On this one I would subtract 5, divide by 3, so x would equal a negative 5/3. So there's those. Let me check that one real quick, or at least check one of those. I'm going to store negative 5/3, so negative 5 divide by 3, storing for x. Now on this one, I always like to go back to the original just in case I do something wrong in my very first step. So I'm going to type in the left-hand side, see what that equals. Okay, type in the right-hand side. Now if I end up with the exact same thing, 33.333 does equal 33.333. So negative 5/3 does check. And you can do the same thing to 1/4. Alright, let me look at the last one. I'm going to subtract 121 from both sides. Binomial, I have no common factor, so it is a difference of perfect squares. So I'm going to have 10x plus 11, 10x minus 11. Set them individually equal to 0. And this one would give me x equals a negative 11 tenths. This one would give me x equals 11 tenths. So I've got a negative 11 tenths or 11 tenths. So here's some examples solving quadratic equations by factoring. Now the other one I was referring to in this particular video is solving quadratic equations using square roots. So the principle of square roots for any real number k. So if x squared is equal to k, if I can get the equation to a point where I've got x squared or a quantity, say a parenthesis squared, then I can take square root of both sides. Remember, when you take square root of x squared, you get x. Also, you've got to remember this little plus or minus thingy. That comes in handy, because normally I end up with two roots, so please remember the plus or minus. Now, in this piece right here, I did a problem by factoring and also by square roots to show you it works. And either one of these work. It just depends on what you notice that you can use right at the very start. So this is a difference of perfect squares. I set them individually equal to 0, so I have x equals negative 6 or x equals 6. In this one I solved for x squared, so I could take square root of both sides, remembering plus or minus. The square root of 36 is 6. This is read x equals plus or minus 6, which is the exact same thing I have here. So I've got some problems, so I need you to again pause me and work these problems, start me back up, and see if you end up with what I do. Right? And solve these using the principle of square roots. Oh, well, I got ahead of myself. We now have a method that can be used to solve equations for which factoring is impossible. This, I can factor out a 2, but after that, I'm still left with an x squared. So try and solve this equation, the very first one, get x squared by itself, and see what happens. So hopefully you've done that. You should, let me see, add 10, divide by 2. So I've got x squared by itself. I'm going to take square root of both sides, remembering my plus or minus. Move my box down a little bit more. So square root of x squared is x. So let me get rid of this. So x equals plus or minus square root of 5. Now this is an exact answer. If you put square root of 5 in your calculator, you'll end up approximately with 2.236. Your instructor will tell you if they want exact and or approximations. So you've got to play the game your instructor tells you to do. So in this one, my x squared is already by itself. So go ahead and take square root of both sides, remembering plus or minus. Now the thing about square roots, especially when you have a larger number, you might have a number that contains a perfect square factor. So here, if you look at 84, naturally I would think of 4. So if I take break my 84 into factors, I would have 4 times 21. Well, if I've got a perfect square, I can pull it out. So here's 84. I always bring my perfect squares up front. So square root of 4 is 2, but the 21 has to stay in because it's not a perfect square. So this is my exact answer. So let's see what I've done. I also went and got an approximation. Now you can check yourself to see if you simplified your radical. Let me see. Let me put in square root of 84. Okay. Let me put in 2 times the square root of 21. And if I end up with the same thing, that means I simplified correctly. So you can check yourself that way too. Let me put that down. Earlier, I don't know if you caught it, but I said I could get, even if I had a parentheses that was squared, I could still use this process. So I've got a situation here. Take square root of both sides because the squared item is already isolated on one side. And there's my plus or minus. The square root negates the square, so I end up with m minus 3 equals plus or minus square root of 6. Make it go down this way. Whoops, too far. I need to solve for m, so I added 3. So this is the exact answer. Let me get that out of the way. Now I want to show you how we put that in the calculator, just to save yourself some time. Let me pull this over. I'll clear that off. I'm going to do 3. I call this the upper road because it's plus or minus. The plus is on top, so I just call it the upper road. So 3 plus, let me get my square root of 6 and see if I end up with that particular value right there. Now, I don't really need to type in 3 minus square root of 6. Remember, recall, if you do second enter, and if you cursor back in, change that to a negative. You don't have to cursor out, just hit enter, and there's my other one. So you need to try some of these problems and see how they go, okay?